Okay, people, so the video I want you to come to is titled here. All right, I'll put a link it. This is going to show that why I think that the top deck first folded in of the structure like that before it fell forward. Now, NIST is just showing it falling forward. Now, a lot of people are just saying it's falling forward. It's not true. It fell first. Not true. Not that I'm, this is a fact. It's not true. It fell. It collapsed. The roof collapsed first in this capacity. And then, when you finally get the buckling, we see it rolling forward towards us. All right, there's a couple of videos. Now it's just not true. I'll give you supporting data, evidence. So here you can see that I've been shadow banned because this video has a whole 2 years ago a post. It's got a whole 227 views on it. Just amazing. It's what they do, It's what they do. They control the narrative. Here's another video I have. This is 1,700 views. But here's the title here, if you want to find it. I'll link it. The ductwork is so critical here that if it just rolled forward, that ductwork would not be it would have been mangled. But it released, it rolled away from it. That little thing there, that little bit of flange you see there on the ductwork is what mounts into over the block wall. And the only way to get that flange in such great condition is to rotate inwards. Now let me get you some more data for that. So here's your data. This is the top floor. As you can see, there's a sky above us here. Top floor. And what do you notice about the ceiling here? Well, there's rebar that was on the underside of this concrete pad. That was the floor, the roof above. And wherever you see white, well, that's the part. There was no rebar. And it ripped down. It unzipped off the ceiling. Doing so, it unzipped further to where it connects here. This stopped it from engulfing the rest of the building also. The overlap stopped there, and it ripped it through. This is drywall right here. And what do you notice about the drywall? In the drywall are indicators where the rebar ripped through it. Ripped down from the ceiling, the roof rather, and it came in contact with the drywall. And look at the angle that it came in contact with. Perpendicular or plumb, let's say, plumb to the surface, to the ground, to the earth, which indicates that the roof rotated. This roof right here. Shoot! I gotta make sure I don't mess up my video. The roof rotated, as you see the sample here. This piece here is the shape. Rotated downward, inwards first. Butterflied inwards at the roof first. Again, if it was forward, if it just went forward, we would see trails of reinforcement that look like this as it ripped through as it came down. The rebar would leave witness marks through the drywall like that. Those witness marks are not like that. The witness marks are like this, straight up and down, parallel, plumb to the earth. All right, they're plumb to the earth. There are other images that prove this also. But the floor below that one, same thing. You see how it's a little less, it's starting to rotate just a little hair towards the front now, but the roof first goes down. And how do I say that? Well, we see it's held on for a bit, but now we have angled reinforcement. With some reinforcement like this, but more so angled on now. So this is the second floor from the top. All right, the top floor though is very clear that we have the butterfly going in, the roof folding in. So I'll link the other videos in the comments, I think, and you can see now again that the top floor. So when the building was rattled, the roof failed first. Now, the video, to explain that with the video, remember these video cameras, they usually go back in time, sort of like your, I guess some of you people own an Apple phone. You can take a photograph and it magically takes 2 2-second video before the photograph you just took, which is not magic at all. Well, same thing with this. It noticed the motion, and then it went back. The camera, I think, which NIST doesn't talk about, the recording system. They talk about the camera on 7th floor, but they don't talk about the recording system of the building, even so far that I could find. And we know they had a recording system, but they don't talk about that. They don't address that the sprinkler system guy wanted to get hold of the system, and they wouldn't let him get hold of it. They don't address that. They don't address a lot of stuff. They present to us a smoke and mirrors presentation that's very weak, lacking details. And for 4 years and all the millions of dollars they spent, and they make a model up of concrete and that creates that's already been done by multiple universities. There's no reason to duplicate that. Then they also talk about the concrete floor being of different PSI than the columns. I've already did a video on that. Turns out, though, it was in specs of what was required of ACI. And ironically, the structural guy that's talking about this floor differential, PSI versus column, he's the one that also sat on one of the board members of ACI, American Concrete Institute. So why does he not know that that's insignificant? Because the concrete also wasn't shown as crushed. All right, it wasn't shown as crushed in that capacity. The building was collapsing at that point. We don't show a failure of the columns, I call the sausages, a slide failure, if you will. That concrete looks to be pretty stable. Hold on, Bruce just got finished making out with his blanket. Now he gets fed. Hey, Brucey, come on, boy. Good for you. All right, so Bruce the cat, if anybody new to this channel, he's got cancer and he's got treatment going on. But anyway, we'll move on from there. That's my buddy. So you look at that. Now the wire, as it hung on and the building drifted forward, is a tell also. So as it made it down there before it finally released, that's its tell. But the tell of the reinforcement is here, showing the roof folded in. And again, my other videos will show it also. We'll reveal that also. Pausing. So on ACI, per the code back then, there's offsets. And this is a column from the base, from the floor, column. Look at the offset. There is no column right here where one belongs. There's a huge offset. I did a video on that showing that it's everywhere from 15 degrees, 50, depending which angle, where you're trying to find the angle, but it's significant. This is our column area that fails. I'm working on a video that I have, an old video that I did and 4 years ago, and I talk about this in that video, saying that this is where our fracture, let me go back to the, okay, it would be this one then. Our fracture goes this way. Then we have the presentation from NIST stating that the planter boxes are excessive loading on the deck. As we see in the collapse, you can see the planter boxes existing on top of the deck. Why? How? Because they're on top of columns. The load transfer, where the guy put the planters, these planter boxes, they're right on top of columns. That load transfer is right down to column loading. So, no, it's pretty much a freebie, besides the water that would get in there and pool in there, and without a good liner, and possibly create water issues with the concrete. But no, the weight, no. Wait a minute, did I say it? The weight, no. That load is all in the critical shear zone too. It didn't make it out to the tributary area. So, yeah, no. The planter boxes were not a concern. The weight on top of there. The water might have been, but not the planter box's weight, as NTSB NIST stated. Right on top of a column. So, I call BS on that. Now, on this level of the flooring, you can see the witness rebar, if you will, with witness marks. You can see the direction of their break, the way their pad broke. And that, again, just flat, straight down, and there's a rebar. Just as if you flex the wall, push the floor down from the midspan. and the weight of it helped the bottom and top rebar strip itself. Not all of the, some of the top rebar popped, some of the bottom rebar popped free. We only see one layer of one course. That would be the top rebar here. On the bottom, this is the shadow. On the bottom, we see where it popped from the wall. So that helps you configure, you know, this to see the failure mechanism of that. So here, if you look at the bottom left, it's a screenshot 2021, September 2nd. I had this a long time ago. This was the floor integral with the column design, and the PSI would be different based on the floor. The floor levels, they changed the PSI as they went up. What you do notice is that the reinforcement is still engaged inside this concrete. And also that it's plumb with the column. So the floor, when it went down, it rotated parallel to the column, or plumb with the column, if you will, not on an angle. That reinforcement, excuse me, is parallel with the column. So there is no concrete issue with the floors. I already looked into that. They didn't show anything that shows that this, when this was failing, that it separated from this column. I call it sausages, one sausage to the next, which is just a floor linkage, floor column, floor support. So this would be the floor support column, and then here's the floor. And then there's the next column for the next floor up. There is no failure between here. This is great. I mean, it's not spalling. It's not. It doesn't have shifting of the columns as they try to. The offset, yeah, it was off. Cut from one floor to the next. The offset was a little bit there. It happens. They didn't, you know, the quality 1980s. Yeah, survey guy out in the field. Guess not. Okay, so I'll end this short video with this one. This is the content, and this one's got a whole 644 views on this one. 4 years ago, I posted this. 4 years ago, I zoomed, and they only released last year the images of the column cracked wall foundation over here. But 4 years ago, I brought this to your attention then, that this is significant. And what I'm going to show you is that the crack is from here, and a spacing here. And this is 4 years ago. Let's let it play. There's the title of the video, and let's go.
Here we go. So now we have another flower box, this one here.
Flower box, planter box, whatever.
This is a shift off the flower boxes.
Remember, I didn't have access to the photographs that they had, that they released only last June, was it? And they said it was 2 weeks before it. But looking at just the debris field, I'm saying this is a shift. This is a shift, and I said that 4 years ago. That this brought my attention, was very significant to me. And let me run on. Here, listen.
Look, you can see down the block wall now. We can see down the block wall.
Mm-hmm.
Very interesting. You can't see down the block wall over here, but we can see it over here. So we have a rotation, don't we?
And I talk about rotation. See, I'm talking about the rotation. That's what happened there where the deck rotated inwards. And then I'm going to identify this crack more so, as you may see it here, which would be leaning in that direction, the rotation.
We have a fracture here. Get this fracture. Get that fracture line. Fracture line. Right here, see it? See the fracture line?
That's the rotation.
Fracture line. Over to there. Fracture line. All the way back to this side. And there's our separation, a huge separation from the column there. A huge separation.
See, I was really on top of that column. way back then, 4 years ago, that this was a big thing. And remember, and under rectangular array, this is also the column that's the furthest off from being in position with the other three that I triangulated with you.
From the column, one of our biggest. And then here's our fracture line. Now, what came first, the chicken or the egg? There's another piece of material that collapsed on the deck right here. Does it have a fracture line? Where's its fracture line? Past this or that way? I mean, it was hugely impacted. Oh, look, it hit the top of this head. There it is here. Appears to have been decelerated by here.
All right, so there's a fracture line that I'm talking about. And I'm saying it's not from the debris that impacted the deck. That this is before. This is the deflection of the deck is what I'm talking about. So there it is many years before. And this is with that photograph that was released by NIST showing that crack of the deck. Cracked of the planter box. So here's just went faster in the video. You can see the mapping that I did with the blue ink of the fracture line again. And so I'm trying to wrap this up, keep it shorter videos, we just said. But NIST doesn't talk, they talk about the change of plans in this, with this drawing, but they don't talk about how the BMA was removed. How this was a parking deck with a different elevation, that this was 10'10" and this was 11'10". The parking area was 11'10" and this was 10'10". Both changed to be 10'10". So they removed the beams. I call it Cadillac money, if you guys remember. That's what they were saving in the 80s by removing this continuous beam that goes all the way across. And then this also was a beam, and it's an elevation change. So the parking area was treated with more respect at one point. And when they changed and said, we want to change something in the drawings, they said, look over here, we're changing this. In reality, they made the deck all the same elevation, and they removed the structural beams that would have supported the garage area, the parking area. Number one also is that they changed the room from 4 foot. They changed that out to, I think, 5 foot. So the NIST hired a person to go over review the plans, an expert. There was an individual expert to review the plans and plan changes, but NIST is not bringing up that the deck would not have failed had they stayed with the original design. The design changes changed the structural behavior of the deck with the loading of cars on the same pool deck. The pool deck and the parking deck were the same. It was they made a bridge, basically, and on that bridge they allowed parking of cars, and they also had people walking on that bridge deck on another section of it, isolated from cars, but still connected with just reinforcement, still connected. And you have the shock loading of the cars when they come in there and they hydraulically load, they put on a slam on brakes, that they shock load that reinforcement over there. And remember that offset is terrible. That offset's this one. It even shows it as like 4 foot offset. They show it. As you can see this line here in the drawings, it shows over, then it shows this jog up. In the drawings, they literally show how far it's off. They literally show that, almost messed up. They literally show that it's about 4 foot offset to this one that starts our failure, the one we see the cracks by. But it was okay had they add the beam in there. It would have been a much different behavior of the deck. They added, once they removed the beams, they added, I think, 1 or 2 more pieces of steel in this direction, maybe 1 or 2 more in this direction, and that's it. That was it. Now, NIST did their sample of this, but they also said, oh, the shear heads didn't have enough steel across it. But yet, when they show the image, well, I'll go over the NIST video. It's an hour and 40 minutes long. When they show the model they made to do punching shear with, it didn't duplicate the real world field because that reinforcement was all there. And yet he just claimed a moment ago that the reinforcement wasn't there across the heads as designed here, where it says 16 number 5s, and what does that say? 16 number 5s the other direction. And yet their model was more like this than it was the true nefarious statement by them saying that it wasn't the same. I say nefarious because if you look at my video, NIST destroys evidence, then you'll see that where they take part of the steel out and throw it to the ground. If you look up the video, it's called NIST destroys evidence, Champlain Towers. You'll find where you'll see them destroy, and that's when I got shadow banned for showing them throwing the evidence away. And I say NIST because they were running the show. The Army Corps of Engineers was assisting. So I did get a lot of people, engineers, writing me, telling me, it's the wall. It started at the wall. So with that said, it becomes a bias for me that it did not start at the wall. It biased because I think it didn't start at the wall. I think it started in here. And that the first, so here's the first fracture back here. And the other one's from this column here over, back towards me. The other column, the deflection. And once it came down so far, it then tugged on what is existing and drug it down the wall, leaving witness marks, which NTSB talks about my witness marks which I wrote them many times, guys, about the columns. Even though they treat me bad, I wrote them I wrote them a few times about witness marks, about the column heads, about where I think the collapse started. Even though they shadow banned me for saying that they destroyed evidence, they're still the ones that you need to communicate with. So I still wrote them. With that said, you're going to hear me say that how I'm trying to work on, it was 4 years ago when everybody kept beating me up about, it started at the wall. I mean, I had engineers call me on the phone, contact me, and trying to convince me why it started at the south wall. And I'm like, no. And so either NTSB came to their own conclusion like I did, or they saw my content and they believe that like I did. So it's still kind of a bias. But let's hear what I say in this video. This is 4 years ago.
They're not there. Yes, I've been down here pretty damn hard. I've been down, diving in this thing. I really have been trying to see if I can get this wall as our initiating point to get rid of a bias. I don't believe in not respecting my biases. I'm looking for a span, and all of a sudden it just spanned, made over there with some type of craziness. I
can't get it. I can't get that wall moving. The wall moving would have to buckle for it to start the wall. There's no indication it was reinforced that it buckled at the wall. All right, it can't go away because it's confined by the soil around it, so it can't go away. So it could buckle in and come down, but there was nothing indicating that when we see the garage cleared out. So that closed the story on that. It was the one way it could happen. The other way would be through shear there, but the span was small. It was shorter there. But if it was going to happen, it would be over here by the cars. But the problem is that this planter box in the background, this planter box here, shows a fracture like that. It's open. And then like this. It's an open fracture. It's another video I did. So it didn't start the wall, and this doesn't believe that either.
I don't see that happening. I looked at the rest of the structure. Yeah, it's flower pot. It seems like it's a deck, and then they put this on top of it, this block wall on top, and then they waterproofed it, and then they added the drains along with.
Yeah, so I just don't have it happening at that wall, guys. And that's what NIST concluded also. I had it happen just where I instinctively said it did initially. Butterfly failure down here. Butterfly deck failure. So here I'm going to say butterflying and coming up right now.
So that steel right here was here. That's what that steel was. That bursting, that dropping down, that moment of butterflying took place. The failure took place in reality way out here is where the moment was created that had this start fracturing this deck, where it tried to hold on. The deck dropped down a bit, and it pried this up from here. So it was a pry bar from here.
Yeah, so my software I'm using, and I see in the video that I'm looking at now, it looks like I'm touching the column, but I'm more, let's see if it even comes out right. I hope I'm showing it like that. It's just that the software I used did that weird thing. It's a center line is what I'm showing. Where the guy's standing, that's the lowest point. That's the butterfly location, where the guy's standing. Excuse me, right here.
Oh, well, what didn't mean to do that. All right, pried it up. So that way, as the deck went down, it tried to hold on to it. It fractured it from this point. This side, same thing. You know, right about there, same thing there, and you'll get where the real moment was created. And then you get the 45s off of these guys. The beautiful 45s. They're in failures a lot of places. And we get it on the backside of here. The backside of
Okay, so I call one section the alley, I say, and then the butterfly deck failure. Watch here.
Yeah, I named this the alley. So this is the butterfly. And again, butterflies from a roof. A butterfly roof looks like this, and they allow the drainage in the middle. And so I coined the term butterfly puncturing because of the way it's shaped, up and down. Now, how is it that this, I guess I'll just give away a little bit more.
A planter box, it's level, it's flat. The planter box is outside of 9/11, that they're level. It's another video, I'll have to go into it. All right, so thank you for watching, and yeah, this is going to take, I said I would go over the Champlain Tower stuff in this thing. Also, I will go over the Titan. I'm just decided to do the Champlain Towers first because I just jumped into it, and then there we are. This video, I was supposed to hit quite a few more points in this video, but we're at 30 minutes, so we're going to call it a night. Thank you for watching. Thank you for watching, and yeah, you know, I just won't go anywhere, the content, obviously, because it should be lockdown, shadow banned, junk. But I still put it out there for you guys that are still have interest in the hardcore people. All right, love you guys. Thanks a lot for supporting of the cats, the animals, and that's pretty cool. I'm a nonprofit now, so any donations, if you want a receipt, I can get you one. Thank you. Love you guys. I'm out.